So today, Todd is going to be discussing ideas related to lifters and ion propulsion. He is trying to verify a model that when a disk is negatively charged, it'll repel an ion cloud below it and attract an ion cloud above it. And I understand you've also been building an interesting lifter with corona wire made from super thin 40 AWG SS wire. I've actually worked with 50 gauge, so I know what you're working with. It's pretty fine gauge stuff. Yeah, it's like spider web.
Yeah.
Yeah, and you're doing some unique stuff with it, and you've also looked at doing almost like an ion diode. So, sir, let me hand things over to you.
I'll see my screen. Okay. Let me know if you can't hear me. Before I start, we got a new information from Alexei Chekurkov regarding the Graviflyer. And so he said, he told Charlie that he got the questions and basically confirmed what, I've been saying. You can't, the direction of the Tesla coil windings doesn't matter. But he made some new information. He said that the motors are run from the batteries directly, not from the ultrasonic generator. So there's no adjustment on the motor spin rate of the motors that turn the discs. There should be an independent power supply so as not to affect the operation of the circuit, because the ultrasonic oscillator circuit depends on the voltage. That's how you set the frequency. So if the fans are loading the power supply, changing the voltage, it'll change the frequency. So they are supposed to be independent. The wire from the Tesla coil is connected differently inside the coil if indoors. But if I run the device in the field and use the long wires, then I connect the wire with the end to the output of the secondary coil itself. So in the videos, we've seen Alexei just stick the wire down the Tesla coil tube, capacitively coupling it. But here he's saying that when he's outside and he's got the really long wires, he's actually physically making a connection there, which is something I've been saying for a while, that, you need power. You're not going to get that kind of power through a capacitively coupled wire through the insulation. It's just not realistic. So then he gave his procedure, which is first I turn on the high voltage unit, then I start the motors, then the Tesla coil. I start adjusting the parameters of the torsion field. Again, that's kind of vague. Then the ultrasound. I begin to build up the electromagnetic field, driving it into resonance with the gravitational waves. That's debatable. With the right tuning, an electromagnetic cocoon is formed that deflects gravity. There is a noticeable pink glow around the Graviflyer frame that lasts for some time. And then contradictory to what we thought he said last time is I did not hear strange sounds during tuning. So last time I thought we translated it to say he, listened for a peculiar sound. Here he's saying that's not true. The distance between the discs affect the settings. The legs of the apparatus do not need to be insulated, because there was some discussion, I guess Charlie asked about, when the legs touch the ground, is that going to short it out? He said, I've launched the Graviflyer in the field without insulating the legs. The graphic image shows how different types of fields are located, and perhaps this will help to understand the principle, the structure of the field of the Graviflyer. It will seem strange, but I have no other way to understand it. There are no instruments to measure the frequencies and resonance of the gravitational field, and I can only measure the field boundaries with my gravitometer, which is that invention that he came up with, which is basically an LED between two metal plates. And it seems I've answered all the questions. So this was the new information that we got from Alexi this week. This came just I think like Wednesday. So Charlie asked me to share this, and I'm happy to. Okay, so here's what I've been working on, and this is what Tim was referring to. And this is it's one of these discs that Mark made for me. It's 9-inch diameter, and then I made this little cup washer on the top. I drilled out the holes is what I did, and it's on top of a piece of polycarbonate tube where I ran the wire, the high voltage wire, all the way up the tube to get it to come out in the middle, just in case the thing flies. I wanted to balance, you know. So it did not fly, but I sharpened the tip to a point, and you can barely see it in these pictures, but there's this 3 mil wire wrapped like a circus tent all the way around the top between these holes and these standoffs. The standoffs are nylon, they're insulated. And then below it, also there is the same type of 3 mil wire. It just makes like a hexagon between these standoffs below it. And it's, you know, physically closer to the disc, and these standoffs on the bottom are aluminum. So it's physically in electrical contact with the disc. So the wire on top is isolated. The disc and the wire below it are electrically the same. And then I tested this with high voltage. Now, the first time I tested it, I had used NITINOL wire, which, as you're familiar, this wire, when you apply current to it, it stretches or shrinks. And that's the first arc I saw, it just melted. The first arc I saw just melted. So then I rewound everything using stainless steel 3 mil wire, and it didn't, it you know, it works fine. And I want you to see a few minutes of this video here, because the sound these wires make, and basically I have positive connected to the top and negative connected to the bottom. And before I move forward, the objective here is that the wire creates a very strong electric field, just like a lifter, which radiates ions from the air above it. So above it, I have a positive ion cloud created, and below it, for the same reason, I have a negative ion cloud created. And the disc being negative should repel the negative ions below and attract the positive ions above, giving the disc lift. I did not see any lift with this design, but I haven't really spent a lot of time with it yet. But just there, watch what I did. Listen. Sounds like bees. 25 kilovolts.
Your wire is vibrating.
Yeah.
That's the B sound.
Yeah. It gets louder as I go up in voltage.
Yeah. So if you went to 50 gauge, that vibration would go away. The noise would go away.
It's probably ultrasonic.
The other thing that's interesting is you've got
you see these little flashes on the disc? This is what I wanted to show. This is at like 30 kilovolts. These are those little dust nodules Charlie was talking about and Alexi was talking about, is that the ions are literally hitting the disc because they're attracted to it.
Yeah.
It's 30. Interesting. That's what I wanted to show there. Now here's a test.
About 20.
Here's another test.
1 kilovolts. 3, 2, 1.
Oh, wait a minute. No, this is the same video again. There we go. Okay. So this is the next device that I came up with. And this is because I got this Tesla coil that pulses, and it has these spikes coming out the top. And when it pulses, it shoots off like 4-inch arcs. And the 4-inch arcs are laid flat because the spike in the middle is taller. And so the electric field from the one in the middle is pushing the ions outward from the middle. Very cool thing, very noisy. It's a spark gap driven Tesla coil. But that gave me the idea of, in the same principle here, I've got these 6 spikes going around and a spike in the middle with a radiator in the middle. And the whole thing is charged. And when I use this material just to add, so it would hold some more charge rather than a smooth disc, which holds a minimal amount of charge. So these, like a golf ball and whatnot, it's supposed to increase the capacitance. Can't say that it did, but the idea here was that as the spikes are electrified, it ionizes the air above this disc, which then the disc being charged to the same potential repels those ions, pushing it down. So I expected it to gain weight. And it did. So
All right, got a new one. Model E. Badass. I got the scope calibrated. Well, 26, 30 millivolts about. Here's 20 grams. 20 grams is definitely noticeable. Now, I expect from this design, sitting on the scale like this, single polarity, I expect weight gain because it's going to be pushing down on the scale. Let's see what we get. Oh, and I got weight gain. Look at that. I haven't changed anything yet. I'm at about 21 kilovolts. I just raised it up to 25 kilovolts, and it got heavier. Should be about 28 kilovolts right now. Okay, watch where it is. I just turned it off. Okay, on. Off.
that's so you see right there, it gained weight just like I expected it to.
All right, got a new one.
There's a little close up.
2, 1. Ah, yeah, that looks more like it. Definitely seeing some weight loss, weight gain now. We're up over 105, 110 millivolts. Negative, huh? Negative polarity. Electrons. Shoot.
So you see twice there, I had weight gain demonstrated. I actually demonstrated it a third time. Here's the data.
And we're back here.
Okay, so this was that first one that looked really good. I checked everything. It was about 20 grams was 1.5 divisions. And so going by that as a calibration scale, I saw 33.3 grams of weight gain as it pushed down on the scale. So it was repelling the ion cloud above it, pushing down. I did try to turn it upside down on the scale and see if it would lose weight, but because it's in contact with the wood, I don't think there's no cloud underneath it. You know what I mean? There's a piece of wood underneath it. Okay, so then I tried hanging it, and this was just yesterday I did this. I set it up and I hung it. I put the videos posted on Warp Drive Tech. It wasn't that eventful because it killed my power supply, but the high voltage basically generates enough high voltage noise that it backfed through the isolation barrier to my 300 watt 30 volt power supply and killed it. So that was where I left off, but I did get some data hanging it like this. And so with it, the way you saw it in the image, I saw about 6 grams of weight gain, still the same scale of about 1.5 divisions is 20 grams. So, so I saw about 6 grams of weight gain. And then I turned it upside down and hung it. And this was the only shot I got before the power supply died. And it didn't look like anything happened. So upside down, I didn't see any weight loss. It is kind of close to the floor, closer than I wanted it to be for this test. And before I got a chance to make any modifications, the power supply stopped working. I don't want to risk, I have another one, but I don't want to risk it because it's the only other one I have. And I have a new power supply that supposedly can go to 60 kilovolts coming today or tomorrow or Monday. It's supposedly out for delivery this morning. So when that gets here, I will continue. And that was it. So that's where we're at. Back to, I had some good data and good test. I have several of these new devices to test, and it's just a matter of I need more voltage. So
Todd, thank you, sir. And I hope to have you back many more times to share updates with us. Same bat time, same bat channel. That just popped into my head, even though it's ridiculous.
Right. Yep.
Yeah. Thank you.
Not a fan of Batman.
Okay, so let me put this on gallery view. Everyone, please give Todd a hand.
Thank you.
And our undying thanks for your many presentations